Today I will talk about the workflow of using the Blender plugin, BoneX, for character physics. Before we begin, we need to plan our collision settings. Proper planning can reduce unnecessary collisions and improve performance, allowing you to quickly achieve the desired effects and reduce debugging time. In my example, the following plans are included. First, we need the leg collide with skirt, then turning off the self-collision for the skirt. Next, the hair needs to collide with the head, shoulders, and torso. The chest and decoration are set to have no collision. They do not collide with any rigid bodies. Then, it's about assigning layers, following the above plan to assign a layer. The description on the right describes the layer functionality of this add-in. Next, we will demonstrate the physics effects using an MMD model. First, let's import an MMD model. We first need to group the character's bones. Here, the groups have already been assigned by MMD tool, which is beneficial for us later when assigning physics bones. First, let's look at the skirt. We need to check the orientation of the skirt's bones. Turn on the bone axis and armature settings. We can see the axes of the skirt's bones. They are all facing the same direction. This is not good for later when assigning physics bones. This time, we need to correct the orientation of the skirt's bones by entering Bone Edit mode. Pressing Shift and N. Selecting the cursor. The cursor around the skirt's bones will rotate towards the cursor direction. After the rotation is complete, we can observe that their orientation is now better. Now we can reassign the physics bones again. And we find that the bones match the direction we want for the skirt. And let's continue with the operations for the skirt. After assigning its shape, we need to set up the physics bone group. We plan the skirt's physics bones are belong to the second group, and it collides with the 15th group. We place it in the second group, and let the 15th collision group enable, and its self-collision should be disabled. Let's playback it and check the result. And a simple physics effect for the skirt is completed. Next, we need to assign a collider to the legs. Select the leg bones and press the C key. Here we see it is colored, but we want the legs to be controlled by keyframes. Therefore, we set it to kinematic here. Let's play it again to see the result. This time skirt won't penetrate through the leg. Let's look at the breast simulation. We can see its bone orientation is facing downwards, which is incorrect. Enter edit mode and rotate it. After the rotation, assign it as a physics bone and scale it. Then set up its group. We hope it does not collide with any rigid bodies, so we set its group to none. This way it won't collide with any collision bodies. Let's look at the result. Next, look at the hair. Select the hair bones. After selecting, press C to assign its physics rigid body. And we need set which group it belongs to. The hair belongs to the 3rd group, and it collides with the 14th group. Its self-collision should be turned off. Then, we set up the rigid bodies that will collide with the hair. Select head bone and press the C key and set it to kinematic. Let its 14th group enable. You can see its position does not quite fit. We can press E to enter its edit mode. Select shoulder bones and press the C key. Set it to a kinematic rigid body. Scale it. Set it to the 14th group. After assigning, let's see the result. When the physics of the hair part is also done, and it does not penetrate, there might be a slight penetration in the neck part later. We need to add a rigid body to the neck part as well. Next, we assign the physics bones to the ribbons. Select the sashes. After modifying the shape, we set its layer. First selecting the left ribbon, we hope the left ribbon will also collide with the right one. so we need to separate their collision groups. Select the left ribbon. Set it to the fourth group. Turn off its self-collision. Then set up the right one. Select the right ribbon. Set it to the fifth group. Turn off self-collision for the fifth group. Then the simple character physics is done. We can make some further fine adjustments. Now I don't wanting the skirt and ribbon not to flutter too much. We can select them and set their stiffness. And it won't flutter so much. Sometimes you might feel breast movement is not enough. We can try to understand its principle. In this add-in, each collision body's center of mass is located at the end of the bone, which is this part. If a rigid body wanting to rotate, then it needs to resist its spring. So its lever arm is very important. So you can try to make this bone longer to get a longer lever arm. Is to modify its mass. Mass can also be used to resist the force caused by its spring. Both methods are viable. Now, the physics bones for this character is completed. Next, we apply an action to check the result. Here we can see the lower leg and the skirt have a penetration issue. This is because when we assign the collision, we did not set the lower leg as a collision body. We select the lower leg and assign it as a rigid body. After physics is applied to lower leg, the mesh still penetrate, but there is no penetration between the rigid bodies. This is because the neighbor bone chain is moved too far to each other, leading to the skirt's mesh stretch. And this make the lower leg and the skirt have a penetration issue. We can solve this issue by adding soft connections, which can add a horizontal pulling force between bone chains. Select the skirt's bones, then press Ctrl and W. Choose tube-shaped. Set their spring stiffness to 10,000 to make sure they have enough force to pulling together. Replay to see it again. Now we can see they have a horizontal force, pulling them together horizontally, thus there's no mesh stretching, preventing them from penetrating. Here we see it has a slight jitter. We can increase the iteration to get an accuracy result. After that, there is no jitter here. We apply another action to test the effects. Next, let's look at the use of presets. Sometimes we need to create physics bones for multiple characters, and some params are repetitive, so we need to save the params as preset. First, we need to create a new preset. Click the plus button. Enter the preset name. After setting, we select the skirt's bones. And then click Save button. Select the preset name we want to save. It is successfully stored in this preset. Next, we try to delete the physics bones of this part. Press Ctrl and Alt and Shift and C to clear all physics bone data. At this time, we press C again to assign it as a physics bone. Then click the Apply button. Select the preset name we want to apply. After clicking, we can see the previously set bone parameters and its shape are reassigned to selected bone. When we click the Bake All button, even without ticking the real-time simulation button, these physics bones can still move. This is because the Bake Animation button baked all the physics bones movements into the keyframes. The keyframe bar of these physics bones, we cannot see any keyframe is set, because these physics bones are driven by empty objects. This plugin uses empty objects to drive the movement of physics bones. We can select bone and click Switch button to view the empty objects. We can see the corresponding empty objects have keyframes set, and these keyframes are used to drive our real physics bones. But sometimes, we want to use these animations in other software. How should we output the animations? We switch back to the bones. Select the bones we want to bake. including the skirt part, the hair, and the two breasts. After selecting, we need to use Blender's built-in baking function to bake the bone's constraints into real bone's keyframe. In Pose mode, click Pose. Select Animation. Click Bake Action. In this option, we need to enable these for options. This option is because we only want to bake the selected bones. This option is to assign the real movements corresponding to our bone constraints to the bone. This is to clear our physics bone constraints after baking. Then this option is to apply the keyframe to current action. After checking, click OK. Our bone's constraint is clear and the keyframe is baked into the bones. Now, it can be exported to other software. Sometimes we want to fix some keyframes and do some repairs to the animation, but if we directly select the bone, it is impossible to move. This is because the physics bones have a bone constraint. If we want to manually modify this bone, we can see in the tool panel, there are several buttons to enable and disable bone constraints. If we click Disable button, this bone corresponding bone constraint influence is set to 0. Now you can manually rotate and move the bone. Then, using with keyframes, we can manually control this bone for a certain period of time. For example, I want to manually control this bone at frame 60th. We select this keyframe button, then click Disable. Enable it in the previous frame. Then we want to restore its simulation at frame 70th. Press Enable. Disable it at frame 69th. From frame 60th to frame 69th, this period, this bone is controlled manually. And after that, it is driven by our bone driver. In this period, we can manually rotate this bone. That's all for this video. Thanks for watching.